Okay. Now, all right. So in our last class, we saw some analysis for process synchronization using binary semaphores as well as the counting semaphores. These are binary semaphore is very good approach. As I mentioned, that almost every operating system nowadays use the binary semaphore approach to for process synchronization. Also, another approach is counting semaphore. Counting semaphore, you may use these algorithms whenever actually you need to access more than one process inside a critical section. At this time, you can use the counting semaphore, and then actually we talk about some topic concept for these deadlocks and why also some necessary condition of deadlocks. Why actually deadlocks happen and what is the necessary condition for deadlocks? You know that there are also we saw that there are total four steps or necessary condition for a deadlock. One is for mutual exclusion. If deadlock can happen, of course deadlock happen if there is a mutual exclusion. If you maintain the mutual exclusion properties. Also, if there is hold and wait, and there is no preemption of resources and circular wait. If you disable one of these properties, then deadlock will not be happen. These are the four necessary conditions for a deadlock. And next we talk about the types of resources. You know there are two types of resources. One is the single instance resource, another is multiple instance resource. Single instance resource is nothing but your if you think about the CPU, if it's multi-programmable computer systems, you know that if it is multi-programmable computer systems, then you have only one CPU. Means that this is a CPU is one of the resource, so it is a single instance resource. One computer, one CPU. So it is single instance resource. And if it is multi-processing machine, then there will be more than one CPU. If it is more than one CPU, then it is we can say this is multi-instance resource. Here resource is the CPU. If you think about the CPU is here multi-instance of resource. Also, we figure out that the minimum number of resource for avoiding the deadlocks. If there is n number of resources required to complete the execution for a process, then you need to assign n minus 1 resources for every process, and then you need to add one more extra resource for avoiding the deadlock. Okay. So for avoiding the deadlock, and if you think about the process and resource, let's say process you have total 3 process, and you need total and this process need 2 instance of resources. Then you need to assign all 3 resources n minus 1. Here is 2 resources. N is nothing but total number of resources required. So here is 2 instances required. So 2 minus 1 is nothing but 1. And then so one instance of resources you need to assign every process, and then you need to add one extra resources for this resource to avoid the deadlock. So these are actually summary for our last class. So let's start our today's session. Today we'll see one of the new module. This is the file system. Okay, we already complete the process synchronization and deadlocks part. So today we'll actually jump to another module, which is the file system. This is also you'll find in your syllabus as well. This is a file system, one of the last topic, and then we have a couple of others topic, and we'll talk one by one later. Okay. So let me share my screen before starting the file system. Let me turn off the video now. All right, now before we start the file system, let's see what is a file. What is a file? So any data in your computer we can say it is a file. It is nothing but stored in a format of file, in different formats of file. If you consider this, you have some video, audio, as well as some txt, docs, jpg, all are kinds of file. Also also your program, if you write in a program in c++ is .cpp.c, these are the files, all are the files. So where actually file is stored file is stored, permanently stored in our hard drive, okay, in our hard disk. You know about this, all about this. So any data in program represent inside this hard disk, we call it is a file. Okay, if you think about, this is the hard disk, this is the hard drive. Let's check. This is the hard drive. So this is HDD, hard disk drive, and now so before we starting the file system, so we talk about the what is file. Now let's see how actually HDD or hard disk drive is represented. Okay, you can represent how actually HDD looks like. Okay, hard disk drive looks like. In your hard drives, it's divided into some fixed size of block. Okay, hard drives, you know that whatever your TG, GB, TB, terabyte, gigabyte, it's divided into some fixed size of block. Fixed size of block. Okay. Okay. Now we can say this. What is the size of this block? Actually, it depends on implementation. Size of each block of your hard disk. The block size is most of the instance, we can say block size of hard disk. This block size is 512 byte. Okay, 512 byte. It's most of the cases is follow this convention, 512 byte. Now let's see that if your hard disk size is, if your hard drive size is HDD size, if your HDD size is, let's consider 512 GB is your hard disk. Now let's say that how many blocks will be there inside the hard disk? How many blocks will be there? Let's calculate number of blocks. So number of block inside the hard disk in HDD is nothing but your HDD size and the block size, and the block size. Okay, this is a block size. So your HDD size, if you divide by this is block size, then you get the total number of block inside a hard disk. Okay, total number of block inside the hard disk. So here is 512 GB, and also here is another is 5, and your each block size is 512 byte. Okay, 512 byte. This is nothing but if we convert to the byte, 512 GB will be 5 2 to the power 39 byte, and here is 2 to the power 9 byte. This one is 2 to the power 9 byte. So byte is cancelled. So your total number of blocks in here 2 to the power 30 blocks. Okay, this amount of this number of blocks is available inside this hard disk if your hard disk size is 512 GB. Nowadays 1 TB hard disk is available. So from here you can imagine that million of blocks can available inside a hard drive. Okay, this type of small block is million over millions of blocks is resides inside the hard disk. Okay, this is block. So so from here you can see that at first in hard drive there is a small fixed amount of block, and each block size depends on actually implementation. Most of the cases it follow the 512 byte, and if your hard disk size is 512 GB, then this amount of block is available inside hard disk. Now let's check this. Let's see that how actually you actually file a file actually reside in the inside the hard disk. Okay, let's see you have a file, any kind of file. It can be, let's say it is one jpg jpg file, and its size is, let's say, file sizes this file size is, let's say, 2048 byte. Okay, byte 2048 byte, but the file size is 2048 bytes. All right, now let's see that so how many block for this for this specific file, how many block will get? You need to divide it to file size divided by the file block size. Here is, you need to know about this. You need to take a note, or you can take a note. This is a block size for hard drive block size. Here you think about a file. It can be any file, jpg file. I consider here jpg file, and its size is 2048 bytes. 2048 bytes. Let me clearly write in here. Its size is 2048 byte. So how many block will be inside this file? For this file, how many block will be there? So you need to divide it by using this file block. This is the hard disk block, and you need to divide the file block. So usually file block size, of course, it should be equal to the hard disk block size. Okay, this size is same. Hard disk block size, whatever you implement, you consider here 512 byte for hard disk block size. So file block size should be equal to 512 byte. Okay, same as this hard disk block size. So how many block for this hard drives, for this for a single file? Let's see, here is 2048, and you need to divide it by this file block. File block is same as the SDD block. So this is byte cancel. It is nothing but, I can say, this is 2 to the power 11, and this is 2 to the power 9. So you'll get 2 square means 4. You'll get this total 4 block. Block size is 4 for this file. Okay, this is single file, and you get total 4 blocks. So what you can do now, this is the file. Let's say this is file f1. This is file f1. So you can, this file contains total 4 blocks. So one block you can, let's see, this is 4 blocks. This is, you can say, this is the 0 number block for this file. This is 1 number block for this file. This is 2, and this is 3. This is 3 number blocks. This is 3 number blocks. So total 4 blocks for this file. Each block is 512 byte. Same as this block. So this 0 number block, you can fit it 1 block in here. Let's say this is 1 block, and then next block, where actually you set this next block. So there is 2 types of file allocation methods. You also know about this memory allocation methods. There same as this file allocation method. There is 2 types of file allocation methods. One is for contiguous allocation. One is, we can say this, one is for contiguous file allocation. and another is non-contiguous. Non-contiguous allocation. Non-contiguous allocation. These are the two methods. Okay, keep in mind two methods also for file allocation. What is the contiguous allocation? Let's say you from this file is zero block. You just put in here. You just you write in here this block, this file number 0 block in here, and then contiguous will be, you can for contiguous you need to set this to one number block, just adjacent block. Okay, one here is one block file block 1 should be the adjacent for the 0th block. Okay, so here, and then 2 is should be the here, and 3 should be the here. So file block 0 is in here, 1 in here, 2 in here, 3 in here. So this is all adjacent block. So this is called this contiguous allocation, file allocation. In case of non-contiguous allocation, means that 0 block you just, if it is non-contiguous allocation, 0th block you insert in here, but and 1 block shouldn't be adjacent. You can put another location shouldn't be adjacent location. Then we can say this is the non-contiguous allocation. All right. Do you have any confusion or any questions in here? Okay, please take a note in here. What is contiguous as well as the non-contiguous allocations. The file block for a single file blocks that contains some block as well. So each block, when you write this file inside a hard disk, when you write this file, store this file inside the hard disk, this file blocks is locates adjacent location of each blocks in hard disk, then we can say it is contiguous allocation. If it is in different location, let's say 0 is in here and 1 number block is in here, 3 is in here, then we can say this is the non-contiguous allocation. These are contiguous and non-contiguous allocations. There are the two types of allocation. Still, it depends on that what type of allocations you follow in here. If you go for this contiguous allocation, that time read is easy. You just go first, you read this block and then adjacent. This way you can read this file. It is faster, but don't actually don't think that non-contiguous allocation is not a good algorithm, but especially most of the cases we follow nowadays we follow the non-contiguous allocations. We will discuss in later our later class more for non-contiguous allocations. Okay, so non-contiguous is most popular, then contiguous allocation we will see that later. All right, now here you can see that your file size is 2048 bytes, and your block size is 512 byte and 2 to the power 12, and it is also 2 to the power 9. So it is fine. You get this total 4 block. Let me clear some part in here. So you will get total 4 block from here. 2 to the power 11 divided by 2 to the power 9. It is total 4 block. You will get total 4 block. And now let's check this. Actually, 4 block is required. Okay, total 4 block we can say is required for this file. So here is 2048 bytes. Let's see if it is not 2048 bytes. Let's see, it is 2049 bytes. It is 2000, not 48. It is 2049 byte. So how it will look like? How it looks like in now in this case. In this case, it will be the 4 point something. Means that here is all 2048 bytes. It's captured by these 4 blocks, and you have extra 1 bytes in here. You need you have extra 1 byte. Okay, here is this is byte contains 512 512 plus 512, 512, 512, it is 2040, but your file size is 2049. So you have extra 1 byte. Your file contains 1 extra byte. So this byte is in here. So after allocation, after allocates the is 4 bytes, let's say in adjacent location, let's consider this adjacent location. File allocates for adjacent location. If you know this adjacent location, then others will be easy. Then let's see that your file is in this block, also this block, and this block. This is 3, and also you need another block, complete block. And here for this 1 byte, for this extra 1 byte, you need to add 1 byte the next block. Here from this 5 to, you know, this is 512 byte. From here you can use only 1 byte from this block. Okay, now you can say that can we use this? Here is 1 byte, and here is another 511 byte is free. So can I use this byte for another files, let's say file F2, also it has some block, and can I use this extra byte for this another files? Answer is no. We cannot use, each block should be assigned to a particular file. We cannot mix a block by from a different file. Okay, here this file blocks, these SDT blocks already. Here you assign 1 byte from file F1, so you cannot assign any byte in this block. Okay, even though 511 byte is free, you cannot do this. So from here you can see that there is 512 byte. If I magnify this one, 500, this is 512 byte, but you use only 1 byte from this block. So this is wasted. Currently it is wasted. We can say currently it is wasted. So here is you can say it is internal fragmentation problems. You already know about this internal fragmentation problem. You may hear about in our memory management class. So same this internal fragmentation problem in for SDD as well. Okay, this is called internal fragmentation. You cannot use this space for another file. So this is internal fragmentation. But you know that this is a file is currently it is in internal fragmentation. This position this portion you cannot use, but this file is always can be some, most of the cases file is always shrink, and it can be larger. Okay, let's say your MS Word, it is also a file. So if you write more, if you open your file and if you add more text inside your file, then your current file will be increased. So you can use this space for when increasing this file, or you may delete some text from this file. So this 1 byte may not require. Let's say you already delete for 1 byte of portion, so this block will be the free. Okay, this is the actually internal fragmentation problems. But this file can expand, also file can be shrink. Okay, if it is expand, then internal fragmentation will be the reduce. This size will be the reduce. That things actually I mentioned in here. Now let's see that what actually we need to do from this hard disk. We need to read, as well as we need to read some file from this hard disk. We need to read, and also we need to write some file inside this hard disk. Okay, these two things usually we do from our everyday tasks. We read. Let's say when you open a process, you just and your process needs to send to the your computer's RAM or memory. So you need to read some data from a hard disk. Again, when you complete your process, let's consider it is MS Word software. You open a file from MS Word software, and this software also a part of your SDD. Also from here, this software read to your RAM or memory, and then also after modifying this, it's also write back to the hard disk. Okay, to the hard disk. So this is the usually things we do in our daily life. But actually, who performs this read write operation? Who performs this read write operation? It's performed by your operating system. By the operating system. You already know about this. Everything this read write operation is done by the operating system. In your operating system, and let me clear some part again. In your operating system, there is a one already this operating system is a big program. It's very big program. So in your operating system, there is a one function names called, if it is operating system, here is the operating system code, large number of code. Here is one function is called this file system. Okay, file system. Okay, this file system function is responsible to read some data from this hard disk, also write some data to the hard disk. This function actually performs this operation. This file system functions. It is a system operating system function. It is already inside your operating system code. So this operating file system can perform the read write operation for your computer system. So now we can see that this file system is not only perform the read only it doesn't do only the read write performance. It doesn't do only the read write things only. It has it needs to maintain this file system functions. It needs to maintain some other parameters so that the read write operation can faster. Okay, it needs to maintain some other parameters so that the read write function can be the faster. Also we'll see this which parameters it needs to the maintain. We'll see it later. But also let's see some when you open when you want to write this file, when you write this file to the disk, you know that file also converted into some blocks. These things who convert this block by using this file size divided by file block size. These things is done by this file system function. It's when you save a file, it's converted into some fixed size of block as similar as the block size as SDD block. So these things is done by your file system function. And then which type of allocation, which kind of allocation, it will be the contiguous allocation or it will be the non-contiguous allocation. Contiguous allocation or non-contiguous allocation, these things also performed by this file system as well. Also, another thing is that for disk scheduling, we learn different type of disk scheduling method later. Disk scheduling. This disk scheduling also performed by this file system function as well. So what is the disk scheduling? Let's say you have P1, P2, and P3, total three process, and from here each process need to access the SDD. So SDD or hard disk, you know there two processes cannot be accessed at the same time. So there should be some scheduling. Let's say which process will access this hard disk first. Let's say P1, then followed by P2, then followed by P3. or it can be P2 followed by P1 followed by P3. Okay, this kind of scheduling is done by this file system function. Okay, okay, this is the some major tasks for this file system function, but at at least if at first you need to remember this is the main operation for this file system, read and write, and also it also do some others operation as well. Okay. All right. Before we learn the read write operations, how actually file system perform this read write operations. Let's see that some attributes of file. What is what is the attributes of a file? Okay. File attributes. File attributes. Okay. In file, there are different types of different kinds of attributes available. You know about this. It is kind of one is the name of the file. So this file should have name. This file should have name to identify the file or where this file is located. So name should be one of the major attributes of a file system of a file. And then another is attribute is type of a file. Type of a file. So which type of this file? It can be JPG, MP3, or some video file, as well as it can be docs, docx, PPT. So depending on this type, you need different type of software to open or to read this file. Okay, so type is another attribute for a file system. Sorry, for a file. Yeah, and then another is location of file. Location of a file. Location of file is one of the major, if you major component for a file system. If you think about this file system uh, to access this file, to access this specific file, this file system uh, this file system is actually needs to identify where actually file is located, Otherwise, it is very time consuming. Let's see, this is your SDB. If it is SDB, here is different types of block. Okay, millions of block in here. Okay, millions of block in here. Let's say your F1 file. F1 file is starting here, this block. Okay, here is millions of block. So in terms of, if you don't know this location, then you start from searching from here, and here, and then you will get this block. If it is more down, then you need to actually go through this all of this block, and this is very time consuming. But if somehow, if you know the position of this file block F1 is file block. If you know this file block, then what you can read this file very easily or faster way. Okay, so location is very important parameters for a file system. And next is fourth attribute is size of a file. Size of a file. Of course, this file some sort of sizes. Yeah. So size, you need to know the size of a file, because to make this file block, you need to know the size of the file as well. Okay, how many blocks should be a particular file? Then to compute this block, you need to know the size of the file as well. And fifth point is we can say that protection information of a file. Fifth is protection information of a file. This is the protection information of a file. you know that if you want to share your file with your friends and some others person, you know that in if you computer is connected by well LAN or local area network, you can share your file from your computer. Also, if you think about your website, your web browser is in some server. In some server, you hosted in one mm, website in a remote server. So and if I browse your server, ask for the server, then you need to maintain some protection in here. Okay, this file, whether I will read or I write or I can delete. Okay. So from here, if it is a website, my permission should be only the read this file. I cannot write as well as sometimes yeah, I cannot write as well as I cannot delete. Okay, delete. Okay, this is the protection. This protection information you can man is one of the attributes of a file. Okay, this is protection. Also, same thing if you share some file with a local area network in your friends and families. Also, you can uh, you can actually makes the protections. Okay, protections that way that they can read as well as they can read or write, they can edit. Yeah, some things like this. This is the protection information of file. And another is time or time date. This is another number 6. I think number 6 attributes is time and date. When actually create when you create this file, actually when you modify this file, this kind of information maintain this date and time attributes. Okay, these are the attributes. These are all attributes maintained by each file individually. You know, this is for each file individually, not it is commonly used. It's for every attribute should be file F1, F2, every or whatever this file is, 1,000 of it, they have these attributes, and these attributes is known as the also called these attributes. These attributes is also generally known as the metadata. Okay, so this metadata of a file. Okay, metadata. So why you maintain this metadata? Metadata actually these attributes will give you the faster as well as the efficient access, efficient read-write operations. Okay, this metadata will provide you the faster and efficient way to perform the read-write operations. So these are the attributes for a file system. Now let's see the some other items. One of the before I start, let's check another things. Another thing, uh, another thing is kind of how actually you read a file. How you can read a file from a hard disk to from a SDD to RAM. Okay, let's check another some properties. Let's say this is your let's check again. This is the SDD. In SDD, you have some block is 512 block is 5 size is 512 byte of each block, and this is block. This is the block. Also, you have a file as well. File it has also let's say 1, 2, 3, 4 blocks. So 0, 1, 2, 3. This is the block file block. Now let's see that once you this is the RAM. This is RAM. RAM also file. You know that this is and this size is 512 bytes. So it is from this is 0 and 511 in here. This is 512 bytes and 512 to 1023. Here is 1024. This is byte addressable. If you go for this is byte, it will consider this is byte, this 0 1 byte, this 1 2, this is the byte. Okay, so this is till 0 till 512 byte in here, and 512 to 1023 for this block, and so on. Okay. Now let's see that you also this file you allocate, let's say from this block here is also byte. Let's say 0 till 511 byte in here, and here is 512 byte till 1023 bytes in here. So is byte in here, is byte in here, and then so on. And also let's say here also some other byte. It's allocated 0 1 2 3 equal here. Okay, this 5 is now located in here. Now let's see your operating your CPU asks for this data. Your CPU asks for this data to read the let's say 513 bytes 513 bytes from this file. This is, let's say, file F1 from this file. So 513 byte, where it is located, somehow it's, let's say, it can identify this 512 byte, where we'll see that how it can identify. But now we can see that your operating system is identified. So your CPU is request for this data from this 513. Where is the 513 byte location of this data? So 513 byte is in somewhere in this location. So your operating system find out this where is the 513 byte. The now question is that operating system will take this only one byte and send it to the RAM to access the CPU. Also you know that CPU cannot directly access the data to SDD. So CPU will ask the data to operating system to actually pull it from the SDD to RAM. Okay, now question is that CPU asks for this only one byte of data. Now what's actually operating system will do? Operating system will just send this only one byte, or it will send this all of this 512 byte block, this block. There is it's never send this only a single byte. It will read only the block wise. It will read even though this operating your CPU asks for only for this one byte, but your operating system will take this whole actually block to the RAM. Okay, not only a single byte, it will take this whole block, full block. It will take this full 512 byte block inside this RAM, and from this RAM, your now your data inside this RAM. So your CPU can easily access the data from this RAM. Okay. Okay. So here is point is, even though CPU asks for this only single byte, but read will be happened in terms of block, not a byte. So operating system will read the block wise. Actually, it at first identify the where at which block this byte is available. Then it will shift this all block to the memory. Okay. All right. Next is let's see that what is how we can before we read, right, let's take another attributes is called this. What is the logical address and physical address of a file system? What is logical block number as well as the physical block number of a file system? All right. Now let's see that in your before actually start to the read write operation, let's see that what is the logical and physical block of a file system. You know that already you know this logical and what is the logical and physical address when you talk about the memory management system or process management system. That time we talk about the logical and physical address. Now let's see that what is the logical block number as well as the physical block number. Okay, this is the hard disk, this SDD as well. This is the block, some types of block in here. And each block should have this number. So start from this 0. This is 0, 1 block. This is 2, 1, 2, 3, 4, 5, 6, 7, and 8. There is millions of block in here. There is millions of block in here. Okay. Now this is the block number, and also in your file, you know that in our last example, there is total four blocks. Total 4 blocks. We got a one from a one file. I left one. Okay, if it is size is 2048 bytes. Okay, total 4 block. Also in this file you have also this block number as well. This is 0 number block. This is 1 number block. This is 2 number block. This is 3 number block. Okay. So this is the block number. Now when you write this file, to the disk, then let's say 0 number block is in here, and 1 number block is in here, and 2 number block is in here, and 3 is block in here. Okay, this is the block. So this is the block number for this file. Actually, this F1 file, actually where it's located? It's located located from this block number 4. Block number 4 for a SDD, for inside the SDD. So when you read this file, when actually operating system read this file, it needs to know the starting address actually where the F1 is located, starting address of F1 files. So 4 is very important. Okay, 4 is very important. Here is you just clear this block in a RAM, and from this RAM you just write it. Then it is done. You don't need to remember this remember this block number. Okay, now so this block number is known as the logical block number, and this is known as the physical block number. Okay, so this is the logical and physical block number. Actually, yeah, when you read this file, you need to know this physical address where its starting block of F1 is located. This physical address needs to know to read the file. So this is the logical and physical physical block number. So this concept is very important. You need to know about this, or you can take some note as well. What is the physical as well as the logical block number? All right. Now let's see that how you can perform the read operations from a file, or all right, not read. Actually, let's say that how you can read or write a file. Okay, let's see that you open a let's see that you open a MS Word programs, Microsoft programs. Then what it will do? You want to you just open a one file. Let's consider this way. You just open a one file. Then what? And this file contains then what you do. So when you open this file, so this is one of this process. File is nothing but one of the process. Okay. Oh, sorry. When you open a file, so it is open through the MS Word software. So it is nothing but a process. So this software will be loaded inside the RAM, and also you can open the MS Word programs, one file. Let's say you open one file in here, and then after that you just edit something in here, edit some part, and then you just click the save button, then when you click the save button, there is some actually internal function call will be happen. Okay, when you click the save button, your MS Word software, your MS Word MS Word software will make a system call. Will make a system call. It's called this create system call. Create with a file name as a parameters. File name as a parameters. With a file name as a parameters. It's called a create system call. Okay, create system call is nothing but it is, if you think about this operating system code, and then inside this there is, this file system, and inside this file system there is also one function. You can say that it is the create function in here. Okay, create function in here. This create function essentially it's do the it will save the file to the to RAM to disk. Okay, RAM to disk. So how actually it will do this? At first, what it will do? Create function. When you call this create function will make the MS Word document in different blocks. Sorry, in how many blocks actually have to create for? How many blocks is appropriate for this for this file? Let the file name is f1. For this file name f1, so it will divided some types of block at first, and then it will what it will do. Then it will figure out the if any depending on the allocation algorithms, it will figure out some blocks inside the SDD actually where this file is fit to write. Okay, so before actually it's do to write this file, it maintains some other things as well. Once let's say your operating system sorry, your this create function, of course this is a part of an operating system. Your create function figure out that okay, this block, and let's say make it different color. This block, this core block is for this file f1, So if you think only this thing, then it is done. If you think, then it is done. Then when you read this file, then you need to read this file from this block. Starting number is from this full block. So how you can read this? You cannot read this file actually efficiently. Then you need to actually search from this is block and then figure out where is this f1 and you can read. But somehow you maintain this starting address for this file actually where actually it's the where actually it's saved. Okay, to again read this file. So before it's saved to the file inside this RAM, there is it maintains some all attributes of a file. In here, whether this file is attributes means that also this file attributes when it is created, it's created date, and also read write. You know that some type of a file, everything is in here. Type of a file, and then we can say type of a file as well as access permission, location, and yeah, this information is added to the and also location. Everything is in here except the file name. Some others attributes like I say this type of file, location of file, size of file, and protection information of a file, and time of dates of creation as well as the modification. So these are the information is maintained also in SDD, in RAM for a specific for each file that you that actually currently opened by operating system. So these attributes is known as the file control block. In file control block contains these all attributes except the file name. Okay, file name. No file naming for this file control block. It's maintained by using the others attributes. Okay, for others table. In others table, you see that things as well. Okay, this is maintain a file control block. File control block maintain this location before actually it's saved. Before it's saved, it's actually when actually start to save, then it will update the location as well, location parameters as well, where it is, where actually it's located, where actually this file is start to save, from which block this file is start to save. Okay, now uh, now let's see that this information is done. So file information, and then so far it is fine. Now there is some others information you need to mention, you need to in file system need to maintain. It is called this file directory. It is called file directory. Okay, file directory needs to maintain by your operating system. The file directory is nothing but a table. A table file directory is nothing but it maintains a table. Let me draw in here. Let me draw in here. So file directory is nothing but a table. It has also, this is table. It has some rows as well as some columns. Some rows and columns. So first column is the name of a file. Name of file. And then next is, let's say, location of file, and then here size, and here let's say access permission, and here let's say this is the type of the file. Okay, your directory. Whatever this name in here, name will comes from this when you call this create function by using this file name f1. So once you save a file, create a file, then it will, of course, when you save a file, you know that you need to give parameters like file name, and then you can save. So file name will be added to a file directory table. File directory table. This is file directory table. Let me write it here. File directory table. Okay, the file directory table. So once you save every file, whatever this file available inside your computers, so everything is maintained by using this file directory table. So if your computer has millions of files, so here is file directory contains the millions of row in here. Okay. Okay, so file information you will find in the file directory table. So this is a permanent, should be saved by permanently. Okay, this saved by permanently in hard disk. So when you save this function, at first your file system is update this fcd file control block, that where its location, and every file control blocks contain some, all of this information is location. Where is location? It is located for, let's say, file f1 in here, and located in 4. Okay, some other information as well. So so when you create when you set this file, so from this file control block you will get this all of this information, and then you just add a row using this file name, and all other information you'll get it from this file control block, and then you can delete this file control block and save it to this file directory to the hard disk for permanently. Okay, so when you read this file, when actually operating system read this file, it will start from, it will searches from this file name. Okay, file name f1 is available in here. Okay, if it is f1 is available here, then it will find this location of this file. Location of this file. So location of this file, location of this file is 4. So it will access this 4, and then this it is also it's know the size of a file. So from here it can say this how many block is allocates for this file as well. If it is contiguous allocation. So if you know this starting point of this file, then it can read all of this byte from this file by the size as well as the block size of a file. Okay. So of course here is important point, it file system maintains a file directory tables. Okay, each file it has a entry inside a file directory table, and it is the permanent, it is always maintained inside this hard disk. Okay. All right. So do you have any questions or comments so far? All right. If no, so today we can stop here, and okay, this is all right, this is the last class for this week. Okay, and see you next week. Have a great weekend.